Hey ladies and gentlemen, welcome back for 9.2. Today we're going to talk about surface area of prisms. So in Unit 9 we're talking about three-dimensional shapes. Yesterday, or in 9.1, we were drawing them with isometric dot paper and orthographic drawings, and we built some in class. And so now we're going to talk about specific ones that are prisms. And so the definition of a prism is a polyhedron with two parallel and congruent bases, and then they are named by the base. So let's go ahead and write that down. And poof, there it happened. So go ahead and pause it and then jot it down. We have some pictures here: triangular prism, rectangular prism, cube, pentagonal, and hexagonal. And so here, these would be our bases, would be the triangles. In our rectangular prism, they're all rectangles, so it doesn't really matter if you picked the two end ones here, or if you picked the ones that are forward, backwards. Cubes, those are all the same. Pentagons, here's definitely our pentagons. These are the bases because they are parallel to each other. And then here is our hexagonal bases. They are parallel and they are congruent to each other. So let's just talk about doing some drawing of these ones. So triangular prism, if we start by drawing a triangle, I'm going to draw 3 vertical lines, and then I'm going to draw dotted lines here to represent, and really I should have drawn that back one a dotted line too. Let's go in and fix that. I wonder if I can select out just that one. Nope, we'll get rid of all of them. All right, get rid of that. There we go. Well, I thought we were getting rid of it. Let's do that. There we go. All right, so we have dotted for our back one. And the reason why it's dotted is because it's in the background of that. So often we are going to see that in a lot of our drawings. And so I just want you to pause and try and draw the pictures that are above and see if you can do those. All right. So then that's going to lead us to some definitions here on the next page. You paused, you drew those. So we have these two pictures here. We have a right and oblique shape. And so if you notice, the oblique one is leaning to the side. And so think about it. If you know anything about your muscles, especially your abdominal muscles, your obliques are on the sides of your abs. And so think about oblique muscles are on the side, and an oblique prism is leaning to the side. All right, so base, definition of a base is our two congruent parallel sides. Two congruent parallel sides. All right, then we have a lateral face. These are the faces that are not bases. So faces that are not bases. And so these would be like, a lot of times kids think of them as like the sides of the shapes. So these would be lateral faces. Okay, a lateral edge is going to be where the lateral face connects. So where lateral faces connect. And so these will be like on the sides here. These pieces are lateral edges. These are where these faces are connecting to each other. Then we have base edges. This is where the lateral face and the base connect. So where lateral face and base connect. So these are going to be all around the edges of our base. Okay, that is where our lateral face connects with our bases. Then we have altitude, and altitude is also known as our height, and this is a perpendicular line segment to opposite bases. So perpendicular line segment to opposite bases. So in something that's just a right shape, it is going to be, the altitude is going to be any of these lateral faces. This is our H, this is our height. But in an oblique one, when it's leaning, the lateral edge is not perpendicular to our bases. So our altitude is actually on the outside to make it perpendicular, or our height is on the outside to make it perpendicular. All right, now we're going to talk about a cross section. A cross section is a cutting that is parallel or perpendicular to the base of the shape. Okay, so a cutting that is parallel or perpendicular. I used my shortcuts, parallel or perpendicular to the base. So really what this is saying is I can, if I scroll back up to my shapes up here, if I take and I cut this in half, like that, and I open it up, what shape are you going to see right here when you open it up and look at that face? Now, if you're in class, I might take some like clay or Play-Doh or something like that, and actually cut it and open it up for you to see. It's a little harder when we're not in class, but that's it. That would be parallel to our bases. Perpendicular to our base would be if I go right through the middle and I open that up. And they each are going to look different. If it is parallel, it is going to be the base shape. So if it's parallel to my base, it's going to have the same shape as my base. If it is perpendicular to my base, it is going to be a rectangle. All right, let's get in to talking about specific types of area. And we're going to talk about lateral area. Lateral area is the sum of the area of the lateral faces. So sum of the area of the lateral faces. So you could think like the sum of the sides, the ones that aren't the base. So if we look, we have a triangular prism here, and what they've done is they've kind of opened it up, sliced it like right here, and unfolded it. This is the net of it. We talked about nets in 9.1. So the dark blue portions are our lateral faces, our sides. So let's talk about how would we find the area of these? Well, these are all rectangles. And so we would take A times H to get that area. Here we're going to take B times H to get that area. And then the last one, you got it, is going to be C times H. Now if we add all of those together, AH plus BH plus CH, is there something that is in all three of those terms that I can factor out? And there is. I can factor out an H, and I'm left with A plus B plus C. Now, A plus B plus C happens to be the perimeter of my base. And so that's our lateral area formula, is the perimeter of the base times the height of the prism. So perimeter of the base times the height of the shape, height of the prism. And so you'll see that here in that picture below, the perimeter of the base times the height of the shape. All right, we're going to go ahead and answer some questions here now based off of this picture that we have to the side. So it says, what type of a prism is this? So we want to name it. Well, what is my base shape? What are my two bases that are perpendicular? Well, they are parallel to each other, sorry. And that is going to be a triangle. So this is triangular. How many vertices does it have? Now, a vertice is where my corners are. So like here would be a vertice. There, here, 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 and here. So we have 6 vertices. How many faces? Now, this is talking about all of the faces, including bases. So we have our 2 triangle bases, and then we're going to have 3 on the side. So we have 1 for this side, we have 1 that's over here, and then we have this one on the bottom that it's sitting on. So we have 5 because we add in our 2 bases. And then it asks how many are lateral faces. Those are going to be the 3 that we had just marked out. So it's the number of faces minus the 2 bases. How many edges? We want to count all of the edges. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. What shape of the cross section is parallel to the base? So if you look back above, parallel to the base is going to be the base shape. So this one's going to be a triangle. And then lastly, it says find the lateral area of the prism. So we need to know, do we have the perimeter of the base shape? And it's a triangle. We are missing our hypotenuse, but it does tell us that it's a right triangle here. So we're going to go ahead and do our Pythagorean theorem and find that. So think about it this way. 5, 6, you need x. So 6 squared plus 5 squared equals x squared. Go ahead and jot that into your calculator quick. And we find that missing side to be 7.8. So now we're going to do our perimeter. So 5 plus 6 plus 7.8. And we're going to times it by our height, which was 7. Jot that into your calculator. And we get 131.6 centimeters squared if you needed a label. All right, I want you to go ahead and pause the video here and see if you can answer a lot of these questions for me, and then come back and we'll compare answers. And if you didn't get something, then hopefully you'll get it then. All right, so pause the video here. All right, welcome back. It's a hexagonal prism. It has 12 vertices. Think about the vertices. You're going to have one on each of the vertices in the base, and then you're going to times it by 2 because you've got 2 bases. How many lateral faces? There are 6 of them. Ooh, how many faces total? There was 8. How many edges? 18. And then if it's a cross section that's perpendicular to the base, so it means we're cutting from base to base, it's a rectangle. Perimeter is 5 times 6 because there are 6 sides. So 5 times 6 gives me 30. And then we times it by our 12. All right, let's move on and talk about surface area of the prism. So surface area of a prism, so we're going to call that SA. Sometimes it's just S or SA, is the lateral area, so the faces, and then plus 2 base areas. Capital B is going to stand for base area. Now that is form is for B is going to change depending on the shape we have. If we have a triangle, it's base times height, divide by 2. If it's a parallelogram, base times height. What if it's a trapezoid? Height times base 1 plus base 2, divide by 2. If it's a pentagon like this picture, oh man, we're going to have to think back to Unit 8. 1/2 times the apothem times the perimeter. Whew, that one. Okay, so we're just going to replace lateral area though with perimeter times height plus 2 base areas. It's nicer to think of it this way, but maybe when you're a junior as an MCA, you're probably going to see it in this form. Okay, so find the surface area of this regular prism. It's a rectangular prism, so it really doesn't matter which shape we want to use as our base area. Our bases. I'm just going to go ahead and pick these ones that are on the ends. You could have picked the 9x4 that it's sitting on. Maybe you pick the 9x6 that's facing us. Either of them are fine. Okay, so let's find our perimeter first of our base. So we have 6 plus 4 plus 6 plus 4. That gives us 20. Okay. Our height, that's our perpendicular distance between bases. So that's going to be our 9. So our lateral area is 20 times 9. So we get 180 for that one. Okay. Now we're going to find our two base areas. So one base area is going to be 6 times 4. Oh, sorry. 6 times 4. So we get 24. Okay, that's one base area. So we have for surface area, we have 180 plus 2 times 24. So if you're typing that into your calculator, we get surface area of 228 feet. All right, that brings us to this triangular prism. So we need to find the surface area. So first, we're going to just find the area of the base. Now remember, you have to get out of your head, like base is what it sits on. Base is not that. Base is the two congruent parallel shapes, which in this case ends up being our two triangles. So we need to find that hypotenuse in that triangle. So you're going to take this 12 squared plus 12 squared. Oops, there we go. 12 squared plus 12 squared equals x squared, because you got to find that missing side. And it's okay if we go to a decimal for that. We get 19.6, no, 16.97. So that, let's go ahead and round x up to 17. I'm just going to put a 0 behind it. So in my notes, I know that that's a rounded answer. All right, so perimeter, we're going to go ahead and add up 12 plus 12 plus 17. And we get a perimeter of 41. So our lateral area is our perimeter times our height. So the distance between the two bases, which is 8. So we type that in. We get 328. Then we need to find a base area. The area of a triangle formula, remember, is base times height divided by 2. So 17 times 17 divided by 2 is 144.5. I should write that neater for you in case. 144.5. So that's for one base area. So surface area, we're going to take our lateral area of 328. And we're going to add 2 of our base areas, which in a triangle kind of feels contradicting because we just divided by 2, but that's okay. So when we go ahead and do this, 328 plus our 2 times 144.5. Oop, I put it in my calculator wrong. Okay, 144.5 times 2, and then we add our 328. Okay, I caught my mistake. I was talking and I changed it to the 17, and our bases are not 17. Our bases and height is 12s in those. 12 times 12, and then we divide by 2. There we go. That's where my funny is coming in. So 144 is 12 times 12, and we divide by 2 is 72. There we go. Whew, now it's working out. I was like, it's not working out in my head as I'm writing. Okay, so 328 plus 2 times 72, our surface area is 472 millimeters squared. All right, that brings us to this last one here. It's a rectangular prism. I'm just going to use my 6x6 as my base. So actually, I want you to go ahead and find out the surface area for this one for me. So pause it here, solve for your surface area, and then come back and see how we did. All right, take a peek there, see how you did. Perimeter, height, lateral area, one base area, and then surface area. Yep, that's one base area. Okay, So we have one more little section of this. And we're going to talk specifically this time about cylinders. Cylinders are still a three-dimensional, it's a prism, but it's a little bit different because its bases are circles. And so we don't have like multiple lateral faces, we have one lateral face. So a cylinder is a circular prism. Its bases are circles. And let's talk about what the side or the lateral face is. So think about this as like a soup can, and the lateral face is the label. So if you opened that label and you peeled it off, what shape is that in? It's a rectangle. So its side or its lateral face is a rectangle. All right. So let's go ahead and talk lateral area and surface area for a cylinder. So lateral area is still the perimeter times the height, but we can be specific with a cylinder because the perimeter, the distance all the way around the base, which is a circle, is the circumference. So we're actually going to say 2 times pi times r times my height. Surface area, we're still thinking lateral area plus 2 bases, but this time we're going to be specific. So surface area is our 2 pi RH, which is our lateral area, plus 2 base areas. Well, area for formula for a circle is pi r squared. So we're going to say plus 2 pi r squared. So they're more specific for an area of a cylinder. All right, so find the lateral and the surface area of this cylinder. So our lateral area, we're going to do 2 times pi times our radius. Well, here they have a red line that goes all the way through, so we're going to assume that that is our diameter. So our radius is 7.5. Times our height, which is our distance from our base to base, so that's going to be our 18. All right, go ahead and grab those calculators and type that in. And we want to round it. We get a decimal with pi, and that's okay. So let's go to 848.2 because it was 2, 3, so the 3 is not going to make us move up. All right, so surface area, we're going to take that lateral area from before plus our 2 times pi times our radius of 7.5 squared. So I'm going to use my rounded answer here right now, and then we'll just talk in a moment about how that might change it. So 2 times pi times 7.5 squared. And I get, all right, 1,201.6. So here's the thing. If we do 2 times pi times 7.5 squared, this is 353.4. Now, if we add those together, we get the 0.6. If we would put this and this into our calculator, it is going to maybe round ever so slightly different. So when you do that, it actually ends up with a 0.59, which would round up to 1,201.7. So it really depends on, do you round at each step and add them, or are you going to leave them and put them in whole and round at the very end? So we have a little wiggle room with this, as we've been kind of dealing with in the last unit when we did area of two-dimensional figures. We know we had a little wiggle room with some of them. All right, find the lateral area and surface area of a cylinder with a radius of 5 and a height of 9. So this one's nice, they just gave them straight out to us. So our lateral area is going to be 2 times pi times 5 times 9. And you'll go ahead and grab that calculator. 2 times pi times 5 times 9. we're going to get 282.7. 282.7. Again, I'm going to use the rounded there. If you don't, we're going to just be ever so slightly off. Okay, and then we do 2 times pi times radius squared. So 2 times pi times 5 squared. So 2 pi 5 squared. That part gives me 157.1. So 157.1 plus 282.7. And I get 400, there we go, 439.8. If you typed them in separately, or I mean all together, this one actually rounds to 0.8 also. It ends up being 0.822. So it does round the same. So that's where it's like, well, we got a little wiggle room. Sometimes it's the same, sometimes it's a little different. All right, so I'm going to have you guys do this one. Please pay attention that the diameter is what is given. It is not the radius that is given. So pause it here and solve for our last piece. All right, so with this, my lateral area ended up being 90.5. When I put 2 pi times my radius squared, I got 56.5. So together, they're 147.0. That just tells me that I rounded, or that's just a rounded answer. And if you put in the pi's and all of it together, it actually rounds to 147.0 also because it's 0.02 behind that. All right, and there we have it. It's a long one, guys, but we made it through.